Welcome to our session on normal distribution. We are going to look at how to read a normal distribution table. But before we do so, perhaps I could take you through some key points in normal distribution. A normal distribution is a probability distribution that is bell-shaped, as you can see, which is asymmetrical at the mean. So this simply means that the left quadrant is equal to the right quadrant. So in between here, we have 50% on one side and 50% on the other side. The total probability must add up to 1. The mean, the median, the mode, all at the center, asymmetrical. And the tails don't touch the base. They're infinite. So the normal distribution table is unimodal, meaning it only has one peak. It is not like this. It's unimodal. So the total area under the graph is equal to 1. And it measures central tendency. In a perfect normal distribution, the mean, mode, and the median are equal. So the mean defines the center of this curve. The standard deviation determines the spread of the curve. So it follows the empirical rule, which simply implies that 68% of the data lies between 1 and -1 standard deviation. So this area from here up to the area from here, 50 knots, what? 68%. Empirical rule. Then 95% of this shaded area here, when we shade here, or this area inside, is about 95%. Then 99.7% when you shade from this area. It doesn't touch the base as it looks, but this is about 99 point what? 7%. This is within 3 standard deviations. So the distribution follows what we call a probability density function, a PDF. So the areas here under the graph can be standardized using the formula. Z is equal to x minus mu over standard deviation. The area under graph is highlighted as has been shown. So a normal distribution is used in statistics, economics, psychology, education, and quality control. It helps us understand hypothesis testing better, confidence intervals, how to grade systems, how to forecast risk. In the real world, height, exam scores, blood pressure, all these are often known to be normally distributed. So the Z scores that you're seeing here, from here to here, okay? So this is negative infinite to positive infinite, meaning it doesn't touch the curve. So the area from negative infinite to 1, for instance, you read it under Z 1.0. So when you're reading Z 1.0, you go under 1.0 and under 0. So the area from here up to here is about 0.8413, about 84%. So we have 0.84. So 0.8413. All right, so this is the area here. So can somebody tell me if you have a Z of 1.23? How do you read this area? Z of 1.23. We go under 1.2 and 0.03 where they meet. From negative infinite to that point, the reading is 0.8907. So we are starting from the basic mechanisms of reading. 0.8907. If I asked you to give me the probability of 0.8907 in terms of Z, just add 1.2 and 0.03. This will give us 1.23. You can read it vice versa or in the ordinary. So if you're reading it from that, it's called what? They said. What you get inside is a probability. So from negative infinite to 1.23. So this reading here is denoted by 89%. This whole area here, 0.8907. So if the whole area is 1, so meaning the small area remaining here, we simply subtract 1 minus 0.8907. Is that clear? Question. Give me the probability of the Z 1.96. What is the Z of 1.96? This is Z. What is the probability of 1.96? What do we get?
0.9750.
1.9 and 0.07. What are we reading? 0. What? 9,
0.9750.
50 here, right? Okay. 0.9750. So the probability is written as such. So if I ask you to give me the Z and the probability is 0.9750, probability is 0.9750, meaning our Z is 1.96. Is that clear? All right, so you tell me the area between negative infinite and positive 2. If Z is between negative infinite and positive 2, what is the area? Negative infinite and positive 2.
Sorry, 0.5080.
Negative positive 2 here, 0. What? 2 under 0. What is this area? 0. What?
0.9772.
0.9772. So this is the area from negative infinite to positive 2. What about the area from positive infinite, the area between 2 and positive infinite? Who can tell me the area between positive 2 and positive infinite? So looking at this area here, positive 2 and positive infinite here. How do we get this area here? Since we know that the area from here to here is 0.9772, we simply subtract 1 minus 0.9772. Okay, so meaning the remainder here will be 0. What? 00 2 to 8. All together, the area must add up to 1. Is
Okay,
that
I'm a
clear?
little bit behind on that one.
If the area from here to here is 50% or 0.5, what is the area that is remaining to make 100%? 50%, right? We're using logical maths here. Let's go again. The area from here to here is 80%, 0.8. What is the remainder from here to here? It's 20%, 0.2. Are we agreeing?
Yes.
Yes. Now, all areas are coming from infinite negative to positive infinite here. So the area from negative infinite to positive 2, this entire area here, if it's denoted by 0.9772, this area. So what is the area between 2 and positive infinite? This shaded region here. If we know that this is 97%, we subtract this from 1 to get the remainder because we know this plus this is equal to 1. Is that clear now?
Yes.
It is clear.
Yes, it is.
All right. So now we can go to something slightly tougher. Suppose we are told that our mean is 10 and our standard deviation is 3. Find the probability of x is greater than 16. So to standardize this x, we use the formula z is equal to x minus mean over standard deviation. So we use ISA to illustrate these things. ISA stands for what? I means what? Illustrate, shade, standardize, and apply. So let us apply this. The mean is always in the middle. So the 10 is equivalent to 0 when you standardize it. So 16 is on the right side of 10. So the question is saying greater than 16. So we use greater, GR and LL. Greater means we're shading to the right. Less means we're shading to the left. So greater, we're going to shade to the right of 16. So step 1, illustrate. Step 2, shade. Step 3, standardize. How do you standardize this? 16, x is equal to, z is equal to x minus mu over standard deviation. So what is our x? 16 minus 10 over standard deviation. What's our standard deviation?
3.
3. So 16 minus 10 is 6. 6 over 3 is what?
2.
So the area from here to here, we already know it by heart. From negative infinite to 2, 0 point what? 9772. So what is the remainder here? We subtract 1 minus 10079772. So what do we get? 0 point what? 0228. So who wants to try? Suppose we have been told to find the probability of x is greater than 7. Can somebody help? Let's follow ISA. What we do?
Illustrate.
Illustrate. What is in the middle?
7, is it?
The mean is 10, which is
It's
equal
10.
to
Oh,
0. We start with the data that has been given. Okay. Then you illustrate. Where is the 7? Is it on the right or on the left side?
it's the right.
Where, based on the 7, where are we going to put?
On the left side.
Side.
Side. Okay.
Left side.
Yes. So the left side of what? Of 10. So 7 is
10.
there on the number line. 7. Then is which side are we going to shed?
Should be greater than 7. Where we're going to shed.
Greater is which side now? Left of 7 or right of 7?
Of 7.
Pardon?
Right of 7. Right.
Right here, this side, right?
Yes.
So is the shading big or small?
Big.
Big.
Big. Was this shading big or small?
Big.
This shading was small, right?
More. Yes.
The small shading we subtract from 1. The big shading we do what? We read directly. Okay, so which step are we on,
Come
Isa?
again on the side.
On the application,
How
we are able to see this shading is small. It doesn't cross the middle line. So there are only two types of shading, a small shading or a big shading. If it doesn't cross the middle line, it is small. So this shading is small. It is just on the right side. This shading is small also. It's just on the left side. Okay, this shading is big. It encompasses everything here. And this shading is big. It starts from here, covers everything here. All right, so Isa, illustrate, shade, then standardize. How do you standardize the 7? X minus mu over standard deviation. What is our X? 7 minus what?
7.
10 over 3. Negative 3 over negative 3 is negative 1. So negative 1, when you standardize it, just check negative 1. What's the reading for negative 1? At 1.0. 0 point what? 8413.
0.413.
3.
So are we going to subtract from 1 or read it as it is?
Read the white is big.
It's big, right? So all shadings, all readings that you're seeing here are more than 50%. This is 84%. So it's asymmetric. Of course, the reading for this was implying from negative infinite up to 1. But this is also readable from here. It can also mean that from this side up to that. So we're not going to subtract from 1. We read it directly because the reading is big and makes sense that this is 84%. Is that clear? All right. How about if we're told to find the probability of X is less than um, X is less than is less than 5. What do we do? Isa, we illustrate.
Going to shed.
First, illustrate, our 10 is here. Where's the 5? Left or right of 10?
Right.
Ensure the number line is needed very carefully. Where is the 5? It's on the left of 10. 5 comes before 10. We have 1, 2, 3, 4, 5.
Yes, it's less than 10.
Okay. And where are we going to shade?
Less than 5.
On the left
The
side.
smaller one.
Yes.
Yes.
So what does the application tell you ahead of time? That the shading will subtract from what? From 1. The standard value of 10 in the middle is 0. So we need to standardize this 5. What is the standard formula? X minus mu over standard deviation. So what is our X in this case? 5. 5 minus 10 over 3. What is 5 over 5 minus 10 is negative 5. Negative 5 divided by 3, what do we get?
1 point.
1 point what? 666. So since we only read to 2 decimal on Z, we round off to 1.67. So what is the reading for 1.67?
6.
0.9525.
9525. So can you tell me, is this reading this part or the big part?
Yes. The small part.
How can it be a small part? All readings here, I mentioned to say they're big parts, above 50%.
Oh, sure.
From here to here, it's
The
50.
big part.
So this is 0.9525. So which part are we looking for, the big part or the small part? We're looking for the small part, right? The
The small
shaded
Yes.
part. So we're going to subtract 1 minus that small part. As simple as that. All right. So now let's go to our question of interest. These are 4 plus 7, 10 marks, 11 marks. That will be very easy for you to answer. So let us answer that. 1.3 and 1.4. 1.3 and 1.4, 4 marks and 7 marks. Let's answer that. So what is the reading between negative infinite and Z is 2.5? So the illustration is what? Negative infinite and 2.5. 0 is here, 2.5 is here. So what do we do in this case? We're looking at this big shaded region, right? So do we subtract from 1 or read direct? For
We
2.5,
read direct.
read direct. So what is the direct reading for 2.5?
2.5. 0.9938.
9938, correct. So 0.9938. So this reading is 0.9938. Is it clear? Point 9938. Right, so suppose we have a population which is approximately normal distribution with standard deviation 10. 2.5 and mean 10. So using ISA, you illustrate. What is our mean? 10. And you're being asked
10. I mean,
what is the probability that the measurements taken from the population will have a value greater than 15. So where is 15 based on the 10 on the left, on the right of 10?
on the right of 10.
Now you know your number line, isn't it?
Yeah.
And the word is saying greater than 15, so which side are we shading?
To the right.
After 10, after 15, the
After
right.
10, on the right. So using ISA, what stage are we? Illustrate,
We have
standard
shaded.
shade, and now standardize. How do you standardize?
Using the formula. Z
U over standard deviation.
What is our X?
15.
10.
X is
15.
15, and our
15
mu,
is 10.
and our standard
10.
deviation,
2.5.
2.5. So we have 5 over 2.5. What do we get?
5 divided by 2.5.
5 divided by 2.5
2.
is what? 2.
2.
So the standard of 15 is 2. How about the standard of 10?
0.
Is 0, always in the middle. So application A, what does the shading tell you? Is it big or small?
It is small.
It's small. Therefore,
Subtract from 1.
subtract from 1. So what is the area from negative infinity to 2 without using the table, using your head?
Negative 1.
What is the area between negative infinite and 2? This whole area from here to here.
Maybe
What is the probability?
point.
You.
Somebody
0.9.
memorize it.
0.9772.
Yes, we've been talking about this. 0.9772. So meaning what is the remainder here?
0.028.
0228. How did we get the 0.0228? We subtracted 1 minus what? The probability.
0.
Yeah.
All right?
Yes.
People perish because of what? Of knowledge and understanding. So anything complicated there?
Possible. Yeah.
No. All right. So the homework will be to try question number 1. Given the mu as 50, standard deviation as 8, and the probability between this and that. So
Question.
yes,
And we try question number
1. Question number 1. So for intervals, though I wouldn't. Okay, I'll send you homework. Okay, let me send you the homework based on what we have learned. So this is basic. So we end here unless there are any questions.